The screen is visible?
Yes, sir, visible.
Okay, okay. So here a matrix is given. This is the first question. 1 second. 1 second. So three type of matrix are given here. First one is 1 second. Diagonal and model canonical form. So this is first. And second one is Jordan, and third one is controllable canonical form. So this question is related to the first matrix, this diagonal model canonical form. So the question is, which of the following option has the condition for the model canonical form to be controllable? Okay, so these four options are there, and which will satisfy such that this will be in the controllable form. So the controllability matrix is QC is equal to B, AB, and A square B. Okay, so here B is given here, and this is A matrix. So that QC will be directly first column will be B matrix. So B1, B2, and B3, and second will be AB. So AB will be this B1 lambda 1. Here it will come B1 lambda 1, and here it will come B2 lambda 2, and third will be B3 lambda 3. So this is AB, and then A square B. Okay. So what is A square? A square will be lambda 1 and 0 and 0 and 0 lambda 2 0 and 0 0 lambda 3. So if we'll do the square, lambda 1 0 0 0 lambda 2 0 and 0 0 lambda 3. So first will be lambda 1 square, then second will be what it will be 1 second. So what is the first element for this one? This row and this column will multiply. So that will be lambda 1 square. Correct? Then here it will be 0. So I think it will be lambda 1 square, lambda 2 square, and lambda 3 square. That kind of thing will come. This second into second, then again it will come. So it will be a similar matrix with a square value. Okay. I'm going to write. So this matrix is lambda 1 square, lambda 2 square, and lambda 3 square into. So this one is A square B, A square, and B is B1, B2, and B3. Correct? So and that will be B1 into lambda 1 square, and B2 into lambda 2 square, and B3 into lambda 3 square. So this is our controllability matrix. Is it clear up to now? Okay. So B1, B2, B3. So if we'll simplify this one, determinant, the QC determinant should not be equal to 0. Okay. Then only it will be controllable. Determinant of QC, this should not be equal to 0. Then only we can say that this is the in the controllable form. Okay. So we can calculate the determinant of this one. So I'm taking B1 common. Okay. So B1 if I will take common, then it will be here this and this. So B2, B3, and lambda 2, lambda 3 square. So B2, B3 will also common. B2, B3, B2, B3, and then it will be lambda 2, lambda 3 square, lambda 2 into lambda 3 square minus this one is lambda 3, lambda 2 square. Correct? Is it clear up to now? So the determinant will come as a function of, I'm going to write the final expression. I have the expression. So that determinant value will come as B1, B2, B3, B1, B2 into B3 into, that vector will come lambda 1 minus lambda 2 and lambda 2 minus lambda 3 and lambda 3 minus lambda 1. So this kind of function will come the determinant of this matrix. Okay. B1, B2 into B3 into lambda 1 minus lambda 2, lambda 2 minus lambda 3, and lambda 3 minus lambda 1. Okay. So if we'll simplify this one, we'll get this kind of factorization. Should I do this simplification? Can I reply? can do that also. One second. Is it clear up to now? Can anyone reply? Hello? Am I audible? Faraj, is it clear up to now?
Yes,
Hello?
sir.
Okay, okay. So, uh, okay, I'm going to simplify it. Okay, wait. So that final expression we will get. I'm going to simplify it. This is the final expression b1, b2, b3 into lambda 1 minus lambda 2 minus lambda 3, and lambda 3 minus lambda 1. So based on this one, what will be the option? First I will tell the option. So all lambdas, to make it non-zero, this lambda 1 should not be equal to lambda 2, and lambda 2 should not be equal to lambda 3, and lambda 3 should not be equal to lambda 1. Then only it will become non-zero. So the and b1, b2, b3 should be non-zero. So b1, bi not is equal to 0 for I is equal to 1 to 3. So this option is satisfying. And lambda 3 are distinct, means all the value are different. Then only this QC determinant will not be equal to 0, and our matrix will be in the controllable form. Okay. So that this is the correct option. So I'm going to just simplify it. One second. So first we'll take b1. Okay. b1 into b1, so b2 b3 will come on here. b1 b2 b3 we can write. So one second. b1 b2 b3, and then bracket it will come lambda 2 lambda 3 square minus lambda 3 lambda 2 square. Again I'm taking b1 lambda 1 common, so that will be this b1 lambda 1, it will come like this. So minus b1 lambda 1, correct? And the remaining term b2 b3 lambda 3 square. Okay, so b2 b3 lambda 3 square, so b2 b3 will become common, so b1 b2 b3 we can write. Okay. Okay, so I'm writing like here only. So b1 minus b1 lambda 1, and again here it will be b1 b3 lambda 3 square, b1 b3 lambda 3 square, this into this minus this into this, again b1 b3 minus b1 b3 lambda 1 square, correct? And third will be b1 lambda 1 square. The third one is b1 lambda 1 square, and the terms will be b2 b3 lambda 3, b2 b3 lambda 3 minus, here it will be b2 b3 lambda 2, b2 b3 lambda 2. Okay, so here in all b1 b2 b3 will be common, so I'm going to write b1 b2 b3 common I'm taking, and the first term is lambda 2 lambda 3 square minus lambda 3 lambda 2 square. Okay, minus the second will be lambda 1 lambda 3 square, lambda 1 lambda 3 square minus, this is what, one second, is it correct? b1 b3 lambda 3 b1, one second, b1 lambda 1 I have taken common here, so b2 b3 I think it will be, this is there. Second one, a second one will be this, and this will be crossed out, so b2 b3 and b2 b3, so it will be, this is b2 b3, and here also it is b2 b3. So lambda 1 lambda 3 square, and again it will be here lambda 2, correct? So lambda 1 lambda 3 square minus lambda 1 lambda 2 square, this bracket will be there, and plus here it will be b1 b2 b3, so term will be lambda 1 square into lambda 1 square into lambda 3 minus lambda 1 square into lambda 2. Okay, so here if you'll see, here I am taking lambda 2 square common, so lambda 2 minus lambda 3, and lambda 3 here, one second, lambda 3 square minus lambda 2 square here we are getting, and here 3 minus 2. So 3 minus 2, one second. So all should be different, then only it will become null. So if we'll convert this into the final factorization, okay, so we'll get that kind of term. Where is that? It will come b1, b2, b3, lambda 1 minus lambda 2, lambda 2 minus lambda 3, and lambda 3 minus lambda 1. So is it clear up to now? Hello? Answer is clear? This one? Should I move to the next question? Can anyone reply?
Yes, sir.
Okay, okay. So similar kind of second question is there. So that I'm moving to the next question. So this is the Jordan canonical form. Okay. Here also same thing we have to do. So it is asking what are the conditions such that this will be in this system will be controllable. Okay. So we can write the same thing B, AB and A square B for this one. Okay. So B is given as C1, C2, C3. Okay. So C1, C2 and C3. This is B. I'm writing here QC, controllable matrix. AB. So what will be AB? AB will be this into this. So lambda 1 C1 plus C2. So that will be lambda 1 C1 plus C2. Again this into this. So lambda 1 C2 plus C3. Lambda 1 C2 plus C3. And this row into this column. So that will be lambda 1 C3. So this will be lambda 1 C3. And A square B, again if you write, so A square we can write first, A into A will do. So what will be the A square value that I am going to calculate first? So A is lambda 1, 1, 0, 0, lambda 1, 1 and 0, 0, lambda 1. A, again I will write A. So lambda 1, 1, 0, 0, lambda 1, 1 and 0, 0, lambda 1. So we will do A square. So first element will be this row into this column. So that will be lambda 1 square, correct? Second element will be this 2 lambda 1, correct? This will be second will be 2 lambda 1, this lambda 1 plus lambda 1. And third will be this, I think lambda 1 into 0 plus 1 into 1. The third one will be 1, okay? Similarly, this into this, so that will come as, again, here it will be 0, again it, and this 2 will be, so this will be 0, okay? And the second will be this 1 into 0, 0 and lambda 1 square and 0. So this will be lambda 1 square. And third element will be lambda 1 plus lambda 1, 2 lambda 1. So it will be 2 lambda 1, correct? And last will be this, this will be 0. Again, this will be 0 and this will be lambda 1 square. So this is our A square matrix. Okay. So B, AB I have, this is B. Okay. This is AB and A square B we can write from here. So A square is this matrix. A square into B we have to do. So lambda 1 square C1, okay, plus 2 lambda 1 C2 and plus the third element will be C3, correct? I will just omit it and write it again. So one second. QC is equal to B, AB and A square B. Okay. So this B, AB I have written here. Third, I'm going to write A square B. A square B is lambda square into C1. So C1 lambda square plus 2 lambda 1 into C2. So 2 C2 lambda 1 and 1 into C3. So that will be plus C3. Okay. Again 0 lambda 1 square plus 2 lambda 1. So this will be C2 into lambda 1 square. C2 into lambda 1 square and 2 lambda 1 into C2. So plus 2 lambda 1 into C2. No, it will be the last one. So last C2 is here, C2 into lambda 1 and last is C3, 2 lambda 1 into C3. Again the third if we multiply the first 0, 0 and lambda 1 square into C3. So lambda 1 square into C3. Correct? Is it clear up to now? So now we have to find the determinant of the matrix. Okay. So if we'll find the determinant of this matrix, okay, and we'll simplify it, then we'll find that the final determinant will be QC will be equal to, and the answer. So if we'll simplify this, we'll do the determinant of this one. So that will get as minus of C3 whole Q. Okay. Remaining will be, no component will be 0. So which answer will be correct based on this? Can anyone tell? Which will be the correct option? We are getting the determinant. If we'll get the determinant of this one, okay, so then we'll find that QC is equal to minus C3 whole Q. Okay, so which will be the correct option? Such that this will be in the controllable form. Can anyone tell the answer? Hello, is it clear up to now?
C3 not equal to 0.
Yes, correct. So actually we are getting this only. So to make it not equal to 0, this, because this only variable is coming in the determinant of this matrix. Okay. So if C3 will be 0, then it will not be controllable. The only one case is there, when C3 will not be equal to 0, then only it will be controllable. So out of all these options, this option is correct. Okay. So should I move to the next question?
Yes, sir.
Okay. 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 So this is the third question. Like here, Jordan form, I think, and controllable canonical form. So here also we have to do the same thing. Okay. So if you write the matrix here, so I'm going to write the controllability matrix. So B first we can write B is 0, 0, 1. Then AB. So AB will be, first will be 0. This into this it will be 0. Okay. Again this into this will be 1. Okay. And this third one into this will be A1. Okay. And similarly A square B. So A square first will do. One second. So A square will be A into A, 0 1 0 0 0 1, A3 A2 A1, and this if we multiply with 0 1 0 0 0 1, A3 A2 A1. So first into first will be, that will be 0, correct? This row and this column, so that will be 0. Again this row and this column, that will be 0, and this row and this column, that will be 1. Okay. Similarly for second, it will be A3 and A2 and A1. And for this one, last one, it will be first column, first row into first column, so A1 A3, A1 A3, and this, then it will be A1 A2, A1 A2, and last will be A1 square. Is it correct? A into A square. Okay. So so what will be the A square B? So A square B, if we'll do A square into B. Okay. So the first element will be 1. Okay. Again, if we multiply with second one, so then it will be A1. And if we multiply with third one, then what should be the value? Any mistake is there? One second. See, last uh, first row into first column. This is correct. I think this is correct. This is correct. Here I think mistake is there. So here the fourth, if we'll see, A2 plus A1 square. Okay. First, this row into this column will get A1 A3. Then this into this will get A. This will be, first will be A3 plus A2 square. So this middle part will be A3 plus A2 square, and the last will be this third row and third column element. So this will be this into this. So middle A2 into 1. So A2 plus A1 square. Correct. So our this will be A2 plus A1 square. A2 plus A1 square. So this will be our controllability matrix for this one QC. Okay. So what will be the determinant for this one? If we'll calculate the determinant, so this for this it will be 0, for this it will be 0. I'm taking 1. Okay. So if I will take 1, so 1 will be here, this and this will be there. A into 0, 0 minus 1. Okay. So this here it will be minus 1 to the power 1 plus 3. Correct. Plus minus plus. So it will be equal to minus 1. So determinant is non-zero. It is independent of the variables. Okay. So if the determinant is independent of variable, which will be the correct answer? Can you reply? Hello? Which will be the correct option? Any guess?
Always controllable.
Yes, correct. So this will be the, since it is non-zero value, it not depends on the variable, so it will be always. So in last class I have already discussed, this form is the controllable canonical form. Okay. And if it will be in controllable canonical form, like this will be 1 1 and last will be non-zero, and this will be 0 0 1. Okay. And C will be 1 0 0, I think 1 0 0, something like that. So that will be controllable canonical form. Okay, it will be always controllable. So no need to check the controllability. If you find A like this and B like this, directly we can take the always controllable option. Should I move to the next question? Is it clear to all? Hello. Any doubt is there till now? Or I should go to the next question? Can anyone reply? Should I move to the next question?
Yes, sir.
Okay, okay. So this is also similar kind of question, a fill in the blanks kind of question. Okay. So it is asking what is the minimum number of non-zero elements in the matrix B. Okay. B is a matrix B. So B is, let's say, B1, B2 and B3. So it is asking the minimum number of non-zero element in the B such that the system is controllable. Okay. So same thing, we'll do the controllability matrix QC. So QC is equal to B, AB and A square B. Okay. So that will be first will be B1, B2 and B3, and then AB will be this first row into first column, this one. So A1, B2. So that will be A1, B2. First will be A1, B2, and again here it will be A2, B3, A2, B3, and third will be 0. Okay, and then A square B we have to compute. So 0, A1, 0, 0, 0, A2, and third is 0 0 0. So A square we can compute here 0, A1, 0, again 0 0, A2 and 0 0 0. Okay. So first row into first column, that will be 0, first row into second also, that will be 0, and here it will be A1 A2. Okay. Similarly for this one it will be 0, and this will be also 0, this will be also 0, and third will be 0 0 0. Okay. So A square B if we'll do, so only first element will be B3 A1 A2. That first element will be B3 A1 A2, and this will be 0. Okay. So this is our controllability matrix. So if we'll take the determinant of this one, so this and this two I am taking, so third we can take. So determinant QC is equal to B3 A1 A2, and then this into this minus this into this. So B1 A2 B3, B1 A2 B3, minus b2 square a1 minus it will be b2 square a1. Is it correct up to now? So if it will,
No, sir.
any mistake is there?
B3, A1,
One
A2.
second. This
Yes,
will
sir.
this I am taking as, so this will be 0, this will be 0. So if we are, no, I think I am doing some mistake.
Only A2, B3.
It will be like this, no? One second. One second.
B3, A1, A2, and
So
then into A2, B3, minus A2, B3.
B3 A1 A2 it will be there. So it will be this, like this one, correct?
Yes, yes, sir.
And this into 0 0 and minus 0 minus
A2,
A2
A2, B3,
A2 into this will be
B3.
B3 square, correct? A2 B3 square is correct, no?
Yes, yes, yes.
A2 B3 square. So total will be, it will be minus A1 A2 square B3Q, correct? Minus A1 A2 square into B3Q. So this will be the final determinant value. So how many elements should be non-zero? This is our matrix B. Okay. Our determinant is depending on this B. QC value is depending upon this B. But here only one term is there. B3 is there.
B3.
Okay. So if only one non-zero element will be there, this will be 0 also. Okay. So one minimum number of non-zero. Okay. So minimum one should be non-zero. Then only our determinant will be non-zero. Okay. If two will be non-zero also, let's say this is non-zero and this is non-zero, then also it is okay. But minimum number of non-zero elements is how many? One, I think.
One. Only B3.
Only B3. So minimum number of non-zero element in the matrix B is 1. Answer will be 1. Okay. So is it clear to all? So now,
Yes, sir.
should I move to the next question?
Yes, sir.
Any? Okay. Okay. 1 second. So can anyone tell which kind of form is this one? Like this is a standard form. Okay. Which kind of form? So already I have told previously, this is our controllable form. So
Controllable canonical form.
this is controllable, and transpose of this is observable. Okay. So if you do the transpose, one will come here, and here one will come here, and this positive will come this side. Okay. So if you see here, all positives are this side. One is here and one is here. So this is a standard observable form. No need to solve. Directly we can write for all value of a1, a2, a3. It should be observable. Okay, but we'll solve it and check. So that observability formula is QC is equal to C, CA and CA square. Okay. So this is observable matrix. So we'll write this one. So this is C. Y is equal to Cx. So that is 0, 0, 1. This is C and CA. So CA will be that first element will be this row into this column. So that will be 0. Again this into this. So that will be 1. And this into this. So that will be A1. So first we'll do the A square. What is A square? That is 0, 0 and A3. 1, 0, A2. 0, 1, A1. So same matrix I am going to write one. 0, 0, A3, 1, 0, A2 and 0, 1, A1. Okay. So it will be first row into first column, that will be 0. Correct. This into this 0 and this into this A1, A3. Again this into this A1, A3. This is, one second, this into this 0. Again second will be, I think here I have done mistake. This is first, second element is 1, here it is A3. Okay. So second will be A3, correct? And third will be A3 square. Okay, is it correct? 0, this first into first 0, again this here 1 is there, so 1 into a3, and then again a3 into a3 square. Second row I am going to write, so second row will be this 0 only, and again here it is, last will be a2, and this will be a3 plus a3 plus a2 a3. Okay, and third will be, so for third, uh, first element will be 1. Okay, this into this it will be 1, again this into this it will be a1, and this into this will be a2 plus 1 second, a2 plus a1 a3, correct? So this is our a square matrix. Okay, and if we will do CA square, so CA square will be, first element will be 1, right? Second element will be a1, and third element will be a2 plus a1 a3. Is it correct? Any mistake is there? You can just find and tell me if any calculation mistake will be there. So now we can find the determinant of this matrix. This is Q of O. Okay. So for this it will be 0, this it will be 0. Now we'll find this 1 across this one. Okay. So 1 into this 0 minus 1. So observable will be QO will be minus 1. Okay. So since it is non-zero, it is not depending on the any variables, it will be always observable. Okay. But based on this type of form you should remember. Okay, if it is come in this kind of form, that will be always observable. No need to solve for this one, directly we can take this answer. Okay, is it clear to all?
Yes, sir.
Hello. Okay, so I'm moving to the next question. 1 second. Okay, so here also same thing, we have to check the observability. Okay, so C matrix is given, A matrix is given. So same thing, CCA and CA square. So QO is equal to C. So C is C1, C2 and C3, and CA will be, that will be first element will be 7C1, this will be C2, and this will be 4C3, and third will be, third row will be, so A square into CA square. So A square will be a square of this one. Okay, 49 will come, 1 will come, and 16 will come. So 49 C1 and C2 and 16 C3. Correct? So what will be the determinant for this one? What will be the determinant? QC. QO determinant we have to calculate. So I'm going to write the variables. The final answer I have 51 C1 C2 C3 we are getting. All it will be a function of all. So I'm going to C1. First will be C1. Okay. So C2 16 C2 C3 16 C2 C3 minus 4 C2 C3. Correct. And here it is, second is minus C2, so minus C2, and it will be, how much it will be, 16 into 7, 16 into 7, so 112 minus 49 into 4, minus 49 into 4, 1 second, we are getting minus 84, this into this, 16 into 7 minus 49 into 4, okay, so minus 84, 84 C1 C3, right? Plus third term is C, this is minus A2 already, third is C3, okay. So third is C3 means 7 C1 C2 7 C1 C2 minus 49 C1 C2. Okay. So if you see this one, this pattern, it will come as some constant into C1 C2 C3. Correct. This will be 84 C1 C2 C3. How much this will be? 12 C1 C2 C3. Correct. So C1 C2 C3, 12 C1 C2 C3, this first term, plus 84 C1 C2 C3, and last will be 7 minus 49. How much it will be? 42 minus 42 C1 C2 C3. How much it will be total? So 12 plus 84 minus 49. 12 plus 84 minus 49. Any mistake is there? I think I'm getting some, I think some calculation mistake is there. Found 47 C1 C2 C3 I'm getting. I think some calculation mistake I have done. It should come as 50. Answer is 54 C1 C2 C3. Any mistake is there? See, we'll see it once. So C1 C2 C3 correct. 7 C1 C2 and 4 C3. 49 C1 C2 and 16 C3. So first I have taken common C1. So 16 C2 C3 minus 4 C2 C3 correct. Again for C2 minus C2 I am taking here. So it will be 16 into 7 minus 4 into 49. So 16 into 7 minus 4 into 49. This is correct only. Minus 84 C1 C3. Again if you will take this one, I think it is correct only. Any mistake anyone can find? 714.
Okay.
It's correct only. Okay, I think that then that will be. So anyway, some constant into C1 C2 C3 we are getting. QO is equal to some constant K into C1 C2 C3. Okay. So system will be observable. What should be the correct answer?
A.
Yes.
Option 1.
So all the constants should be non-zero. Then only that will be
Stop.
observable. Okay. So should I move to the next question?
Yes, sir.
Okay. 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 So this is a new kind of question. I think all of you have gone through the lectures. How we can find this K value? What is the rule? Okay. So a matrix is given AX plus BU, and using Ackermann's formula, we have to find a state feedback controller K. The state feedback controller K, where K is equal to K1, K2, K3, such that the control law U is equal to minus Kx places a closed loop pole at minus 5, minus 3 and minus 1. Okay. So the rule is, I think if you can find this in video lecture, so I'm going to write the rule. So first, for the given pole, what poles are given, and minus 5, minus 3 and minus 1. So for this one, we'll find a polynomial phi of s. Okay. So phi of s will be, because here we have to place the pole. So phi of s will be s plus 5 into, this will be a kind of characteristic equation. So s plus 5, s plus 3 and s plus 1. Okay. So this will be s square plus 8s plus 15 into s plus 1. Correct? So SQ plus 8s square plus 15s plus s square plus 8s plus 15. So that will be SQ plus 9s square plus much, it will be 23x plus 15. So step 1, for this kind of question, first we'll find phi of s. This is characteristic equation, or we can say that denominator. So if you have to place the pole, then some function will be there in denominator. That will be the characteristic equation. Okay. And second step is, we have to find phi of a. Okay. Phi of a. So in place of s, okay, what we'll do, in place of s, we'll put the matrix
A.
A. A. Okay. So that will be phi of A will be AQ plus 9A square plus 23A plus 15. So this is a, like it will be a lengthy calculation. We can use calculator. I think in exam this kind of lengthy question cannot come, because if normal calculator, like which kind of like in exam normal calculator will be there, matrix computations are there in that calculator. Have you checked that? Like uh, NPTEL has given the access of that calculator, which you will get in the final exam, like
It is,
3
it is
cross 3.
available online.
Okay, okay. So can we solve 3 cross 3 matrix multiplication in that? Is it possible? Like 3 cross, let's say we have 3 cross, this I want to compute. AQ plus 9A square plus 23A plus 15. Okay. So can we compute this in that calculator? Like if you have scientific calculator, like normal scientific calculator we have, in that we can generate matrix A. First you save the matrix A, then directly write this equation, then we can find the final matrix. Okay. So is it there in that one? If it will not be there, then I think it will be a lengthy question. Like mostly NPTEL questions are objective only, final exam.
Yes, sir.
Okay, so if it will be an objective question, then it will be a very lengthy question. Like computation of this one will not be easy. So I have the answer. I will write the A, this matrix phi of A. So phi of A is, I'm going to write the
Sir,
directly.
uh, there will be a negative marking question, sir, in
Negate.
NPTEL exam.
No,
I don't have any idea. Like last time, have you wrote any other subjects?
no, sir. No negative marking.
No negative marks are there. Okay, okay. So I think you will get the three type of question: MCQ, MSQ, and fill in the blanks type question. So instruction will be given before the exam. I think if negative marks will be there, that will only for MCQ type of question. Okay, maybe it will be not be there also. I think so. You can check before exam. Okay, I think someone is telling it is not there, so I think it will be not be there. Okay, so Q of A will be, we'll find 44. Okay, so if we'll do this operation, AQ plus 9A square plus 23A plus 15, if we'll do this operation, then we'll find the final matrix, this calculation. A is here, so 44, then second element will be 24 and 44. Okay, then minus 88 and then 44 and again minus 24. Okay, and minus 48 and it will be 88 and that will be 44. So this is phi step, this step. Okay, so first this phi a we will get, this phi s we will get. Next what we have to do, we have to find the C matrix. Okay, so the C is equal to B, AB and A square B. Okay, so this matrix will be, I'm just writing directly, 1 2 3, and this will be 0 minus 2 minus 6 and last will be 1 1 minus 3. So this is second step. First step, we'll find the this kind of phi of A, then QC matrix. Next step, and final K value, how we can determine according to this formula, this rule, Atman's formula. So that rule is K is equal to, this we have to remember, K is equal to 0 0 1. Okay, then
To sin inverse.
C inverse into phi A. So this will be that formula. If you'll apply this one, then you'll find final value 16 minus 14 and minus 4. So if we have installed MATLAB, then directly we can find this one. So I'm going to show you that MATLAB code. Wait a minute. So here I have, is it visible?
Yes, sir.
Screen is visible, this MATLAB.
Yes, sir.
Okay. So here I have written that matrix. Okay. What was that matrix? Here first A matrix is there, 101 minus 210 and 021. Okay, B is 101. So like this we can write the matrix 101 minus 210 and 020, and B is 101. So this is the code. Okay, one second. This code is there, A C K E R. Okay, so this code we can use, and then A matrix, B matrix, and we have to place the pole at -5, -3, -1. So we'll write like bracket in this. Okay. So if I'll run this one, let's see, I'm going to run this. So command window we can see, we'll see the result in command window. Okay. So here we are getting the values. How much we are getting? 16, -14, and -4. Okay. So this is the answer. K1, K2, K3. I have written here also 16, -14, and -4. You can also do the matrix computation in the MATLAB also, like for solving the assignments. Okay. Let's say we have to compute this kind of matrix. AQ plus 9A square plus 23A plus 15. Okay. So in that code only we can write. So one second, I will show that. So let's say I am defining a matrix. Okay. Let's say I am defining another matrix. Z is equal to, one second, Z is equal to AQ. So A matrix is already there. Then like this we can write AQ, correct, plus 9A square plus 9 9 into A square. Okay, plus 23A plus 15 plus 23 into A plus 15. Let's see what we are getting. So maybe some error can also come because, okay, it's running. So we'll find the Z matrix. Okay, Z. See, so 44, 39, 59. I think I have already written here. Something, I think some mistake is there. This only 44, 24, 44 we are getting here. S cube, A cube plus 9A square plus 23. One second. A cube plus 9 9A square plus 23A plus 15. 9A square. One second. 9A square plus 23A plus 15. A is 101 minus 210 021. So this we are getting 44, 24, 44 here, but the MATLAB what it is giving 44, 39, 59. I think then either one of that will be incorrect. Okay. So first we'll see like this one. Let's say I'm removing this constant value. Okay. And then we are checking all values are coming as 15 less or not. Okay. So maybe how much we are getting? Z. So all the elements are 15 less than above. So 44 plus 30, 29 plus 15, how much? 29 plus 15. For, how much we are getting? 44, correct? Then 24 plus 15, 24 plus 15, 39. I think this is correct. Okay. So there some mistake will be there. Okay. Is it clear? Like this explanation how we can get AQ, like directly you can do like this, plus last element was 15. Is it clear to all? All of you have installed the MATLAB in your system. If for assignment it will be easier, like if no question will be there, like you can verify the calculations. Okay. So for this kind of matrix, you can do one thing, like if you have the scientific calculator, okay, so you can just define a matrix A. You can define a matrix A in the calculator, then you can save that 3 cross 3 matrix you can define, you can save that. After that you can do this kind of computation in matrix also. Okay, then you will find this matrix, and directly you can, if you have MATLAB, directly you can use this formula K is equal to SEKER AB, and you can find the final answer. Okay, so we have seen that the answer is, if I am running this one second. So command window I will go. You can check the result in command window. So we are getting 16 minus 14 and 4. Okay. So what will be the answer? K1 is equal to, we are getting K is equal to 16 minus 14 and 4. Correct? This only I have written here. Minus 4 or 4. One second. Minus 4. 16 minus 14 minus 4. Minus
Minus
4.
4.
Okay. So this will be the answer. K1 will be 16 minus, it will be 16, not minus 16 I think. K1 is 16. Plus 16 minus 14 minus 4. So is it clear to all up to now?
Yes, sir.
Yes, sir.
Okay. Okay. So same kind of question I am going to show. Okay. So this is conversion from normal. This will be a not a this matrix only. Previous matrix we will convert into the controllable form. Okay. So here we have this form. We have to convert that matrix. This matrix is given here. I will just copy it. Second. One second. So this is the matrix given, and we have to convert this into this form. So some standard methods are there, but I am going to tell you the short trick how we can do. So first we'll find the characteristic equation for this one. Okay. So what will be the characteristic equation? Or any function will be, transfer function will be C into Si minus A inverse, okay, into B. So the denominator will be always determinant of Si minus A inverse. This will be our characteristic equation. Okay. So I'm going to write the characteristic equation for this one. So Si minus A. So that Si minus A will be is equal to S will be, so S minus 1, 0, minus 1. That second will be, here it will be 2, S minus 1, and this will be 0, and third will be Si minus A. So it will be 0, minus 2, S minus 1. Is it correct? This Si minus A matrix is correct?
Yes, sir.
Okay. So we can write the determinant. So first is S minus 1, and this will be S minus 1 whole square minus 0. Correct? And then third element will take as minus 1. Okay. So that will be 2 into minus 2, that will be minus 4. So it will be S square minus 2S plus 1 into S minus 1 plus 4. Okay. Further it will be SQ minus 2S square plus S minus S square plus 2S, okay, minus 1 plus 4. Is it correct? So overall it will be, going to write the final, SQ minus 3S square, correct, minus 3S square, S plus 2S plus 3S plus 3, SQ minus 3S square plus 3S plus 3 is equal, this will be our denominator, characteristic equation we can say. Okay. So our transfer function will be Ys by Us, okay, Ys upon Us, that will be some numerator, okay, divided by denominator. So what will be the denominator? That will be SQ minus 3S square plus 3S plus 3. This will be our transfer function. Numerator will be something that will depend on C value, but since C is not given here, so this A matrix will find this by this denominator part only. Okay. So already I have explained how we can find this A value. So I'm going to write on the next page, Ys upon Us, okay, is equal to some numerator divided by this denominator, SQ minus 3S square plus 3S plus 3, okay, SQ minus 3S square plus 3S plus 3. So this will be a denominator. So how we can find the matrix from this one? I told that constant will assume as x1. Okay. So here x1 dot will be equal to x2, x2 dot will be equal to x3, and this will be x3 dot. So x3 dot will be equal to minus 3x1. This will be minus 3x2 plus 3x3. Correct? This will be x3 plus u. Okay. So these two equation, let's say u is equal to, for A matrix computation we'll do like this. U is equal to SQ minus 3s square plus 3s plus 3. Okay. So this will be our, so x dot will, x1 dot, x2 dot, and x3 dot will be equal to 0 1 0. Correct? 0 0 1, and that will be minus 3 and 3. Correct? Plus 0 0 1 into u. So if you see the answer, like here, this will be the answer. So this is the controllable form 1 1, and here it will come as a1 a2 a3. So a1 will be 3 8 minus 3, a2 will be minus 3, and a3 will be 3. So this will be minus 3 and 3. Some other methods also will be there in the lectures. You can follow that standard method. Some special rule is there, but for that rule will take more time. But in exam, if you follow this short trick, like no need to do the matrix multiplication and all, directly we will find this denominator. Okay, and based on this, we will write this kind of thing, and we will find the matrix. Is it clear to all? Hello? Any doubt is there in this one? This kind of method already I have discussed in the last class, like how to find the state matrix from the given transfer function. Okay, is it clear to all?
Yes, sir.
Okay, okay. Moving to the next question. So this is also similar kind of question that previous question I have discussed. Okay, this already here, this question. 1 second. This question we have solved. So this for same formula we have to use here also, and same rule. This rule is there. This 001 C inverse into phi of A, then we'll get the K value. Okay. So here also the same question is there, but here poles are complex. Okay, our poles are complex. A matrix is given here, B and C is given here. So we have to design a controller K such that U is equal to minus Kx place poles of A minus Bk at minus 2 and this 1 plus j and 1 minus j. Okay. So we have to find these values, K values, K1, K2, K3. Okay. So what will be the K3? Okay. So same thing I have written here in the coding form MATLAB. I will show you that. So 1 second. Is it visible?
Yes, sir.
Okay. So same thing I have kept here. A matrix I have kept here 1 minus 1 2. This B is 1 2 1. C is 1 0 0. And this we can write K is equal to ACKER. 1 second. K is equal to ACKER. Then A matrix, B matrix. And where we have to place the pole. So that is minus 2, that minus 1 plus I, and minus 1 minus I. Okay. So first we'll comment this one. Second. So to comment any, let's say I have written here 2 lines. So comment you can write control R. Okay. If I write control R, then this will not work. Okay. So I'm going to run this. Let's see what value we are getting. So here, 1 second. Is it visible this value 1.812, that last value?
Yes, sir.
1.812, that last we are getting, then 0.3287, then 5.5315. Okay. So going to write there here. 1 second. We are getting as K is equal to 1.8112 to 0.3287, and third value is 5.5315. 5.5315. Okay. So if you see what is asking K3, so K3 is 5.5315. This will be the value. Okay. Similarly, other thing it is asking what will be the L value. So observer is L1, and that pole we have to place at -4, -5, -4, and -3. Okay. So for the this is full order observer whose poles are located at -5, -4, and -3. So what should be the value of the L1? Okay. So in this case, we have to just take the transpose of A matrix. So same formula will be there in MATLAB. I'll show you that. 1 second. So here if you'll see that second part I have written here. 1 second. This one I have written here, L is equal to ACKR, and A to the power dot, a hyphen I have written here. No? So this will make the transpose of the A matrix. Similarly, C transpose I have taken here, and -4, 5, -4, and -3 I have written here. I'm going to uncomment it. So for uncommenting it, we can just put control plus T, then it will, and control plus R means we will comment that. Okay. So I'm going to run this one. Still finding the value of L as, is it visible here? 16, 0.90. This is first is 16, second is 0.9091, and third is 46.4545. Okay. What it is asking here? L1. So L1 is 16. Okay. So that will be the answer. 16 will be the answer. L1 is 16. So here it will be 16 is the answer. Is it clear to all? So for this kind of question, lengthy calculations will be there. You can just download the MATLAB from somewhere, and you can go through this MATLAB code. Then you can find the final answer. Okay. Otherwise, you can solve manually also by using this formula. Here this formula is there. It's 001. First we'll find the QC, and 001 this inverse into phi of A. Is it clear to all? Any doubt is there?
No, sir.
Okay, okay. Any other doubt related to previous assignment, or any other control system doubt? Like this was the last question. If any other doubt is there, you can ask me. Any control system related doubt, basic doubt also you can ask. Hello. Anyone have doubt? Other doubts?
Sir, I have a doubt, sir.
Okay, okay. You can ask.
Sir, in examination, whether we
Okay.
can go for this MATLAB usage, sir? Is it possible? Whether they will allow us to use this
No,
type
no,
of
no.
questions to
Exam.
solve?
No, no. See, lengthy question will not be asked in the final examination. I think this is set for assignment purpose only. I think so. Whatever question will be asked in the examination, I think that you can solve with the calculator or just guessing. Like a standard form, you should remember. Okay. Then mostly like we'll face difficulty in finding multiplication of 3 cross 3 matrix. Okay.
Yes, sir.
So that kind of question will be said like such that this will not be required. Okay.
Okay, sir. Okay, sir.
So MATLAB will be not
Thank
required. MATLAB basically for your learning. Okay, if you are doing this course, then you should learn the MATLAB also, because if you are going for
Okay, sir.
higher studies, it will be required. So for assignments you can
Thank you.
use,
Thank you.
okay, assignments you can use
Thank you,
MATLAB.
sir. Thank
Okay, okay,
you. Okay, sir. Thank you. Thank you,
okay.
sir.
So thank you all. If no doubt is there, you can close the session. Any other doubt is there?
Thank you so much.
Okay. Raj, you have any doubt?
No, sir.
Okay. Okay. So thank you all. It was the last class, I think. Maybe if NPTEL will schedule any further classes, so notification will come. I think. When is the examination?
Okay, sir.
20th.
Thank you. Sir, 20th, sir.
This month
Coming
only.
Saturday.
Okay, okay. Okay. So thank you all. All the best for your exam. Do your best.
Thank you so much, sir.
Okay. Thank you all.
Thank you.